Okay, good morning, Cisco Cohort 1. I'm recording this session today for the benefit of those people that aren't here. And today we're going to cover, I'm going to do the instructor lab demo first. This lab 7.4.2.3 is covering the advanced firewall settings on the standard Windows 10. I'm doing it as a show thing because it requires two PCs. Most people at home would not have two PCs connected with an Ethernet switch, and you can't do it in Packet Tracer. The lab 5.3.1.3, which I'll do next, works from any Windows 10, any Macintosh, any Linux thing. They all run the standard program NSLOOKUP, which you can test to DNS function. So this second lab, I'm going to do first 7.4.2.3. You notice it's got two PCs connected to a switch, and I've got those connected in mine. I'm going to step through and do that on the screen here where we can see this. So let me minimize this. And I'm going to pull up my VMware. I think I've already got the two stations launched on it. PCA, PCB. Looks like they're both running. Okay. So the required resources for this lab is a Cisco switch, which I'm using my classroom switch up here. I've got the two PCs plugged into there. It says one PC plugs into port 6 and one ports into port 1. It really doesn't matter because this is a switch in the default condition. You can plug any two devices into any two ports and they'll be able to communicate with each other. So the two Windows PCs, Windows 10 PCs are VMware, PCA, PCB, and then the Ethernet cables that are plugged in together. You can see these two Ethernet cables that come from the two Ethernet connections on the back of my PC, just like you guys did at machines. Okay, so step one, I'm supposed to verify that the Windows firewall is active. Now, the slight gotcha here is that I have already configured all these PCAs and PCBs to allow ping requests because in all the labs, what are we always doing between PCA and PCB? We're pinging back and forth to see if they work okay. So I'm going to type advanced firewall. This differs slightly from the directions that are in the lab because it was written with a slightly earlier version of Windows 10. Oh, I'm supposed to, first of all, I'm supposed to set up the IP network connections first. So I'll leave this here and I'll click on my shortcut, Cisco Lab shortcut, and go to the properties, and we'll put in the proper IP addresses given in the front page of the lab for this particular one. Okay, the last lab we did, we hooked our two PCs to a home router. We set the default setting. Normally in most of the world, you click the button, the radio button that says obtain the IP address automatically because you want some, Fred, what's up? Now hang loose, I'm doing this as a demo. You won't be doing this yourself. You'll be doing the second lab. I'm doing the second lab first. Okay, you guys aren't connected to the switches back there for this. I'm doing this because of the people trying to do it at home cannot do this one in Packet Tracer. The other lab can be done from any home computer. So I'm going to change this from obtain the IP address automatically to, what is the specification given for, I'm on PCB, I'm on PCB or PCA? Yeah, I'm doing it backwards. I'll do PCB first, then I'll flip over to PCA. So a PCB is specified to be 192.168, focus to it, 192.168.1.11. And if I touch the tab key, Windows will automatically fill in the proper subnet mask. Then I'll click OK. So you guys are not performing this lab. I'm doing this lab as a lab demo. You get free credit for this just by existing in the universe. You'll have to do the other lab though. I'll click OK and click Close. And if I bring on the DOS prompt here to check ipconfig, I'm verifying that it's that proper IP address. So let's go back to PCA and set him to be for his proper address. So I'll click on the shortcut for the lab NIC, properties. Is it still set for what it was last time? Oh, I was using this earlier to do something. Okay, so I'm going to quickly, if you click obtain the IP address automatically and then click back to obtain, it'll wipe out very quickly any previous configuration. Instead of you having to sit there and erase, 8 dots. 192.168, and PCA is supposed to be 1.10. Now, if these were default PCs, by default, Windows PCs will not allow an incoming ping request. because it's dangerous. The malicious intruders, the black hat guys, the threat actors might be using that to map out your network and figure out, oh, I got a ping reply back from that server, and I'm going to try to break into the server and get the secret company information and sell it to their competitors or to the Ukrainians or something like that. So I configure them so they work properly. So when I try this scheme here, if I ping, what's my address, ipconfig, and I'm 1.10. So if I try to ping 192.168.1.11, it works okay because it's not there. But let me show you how you would do this. In the lab, the purpose of this lab is to show you how you would block the pings if you wanted to do so. So we're going to create a new firewall rule on this PCA and on PCB. So I'll close this. And I go to the control panel. If I just type control, go to the old style control panel, which they're kind of trying to hide from you now, but here it is. And I'm going to go to the Windows firewall setting. Now it sort of matches what's in the lab now. In the bottom of page 2, we're told we're supposed to click on advanced settings. And I'll do that. And then we're supposed to click on inbound rules. I've done that. And then we're going to click on make a new rule. Now at the bottom half of page 3, it says we're going to click on the custom button, custom rule, and click next. And then we're going to click protocols and ports in the left-hand column. And where it says any, I'll just click on the, it's kind of like what's on the photograph. You can see all the particular things. We're looking for something called ICMP version 4, which is Internet Control Message Protocol. It's a set of several different things. We use echo request and echo reply to do the ping. Echo request, I send out a message saying, please tell me if you're alive and on the network. It's very short packet, very compact, doesn't take much processing power, although we do have some denial of service attacks that people will send, you know, 1 million pings to Amazon because they're hacktivists and then they're mad at Bezos the Beast and then want to take down Amazon. Fat chance about that. Amazon's got the strongest information technology. By the way, they're 7 years ahead of everybody else on this cloud thing. Yeah, the Amazon SSS stuff, they don't make much money on retail. Pennies, they're like a grocery store. They make pennies on retail. They can lose a little money. They make a ton of profit in the cloud business. That's a big revenue for them. Rant mode off, mark rant mode off. So I'm going to click IP version 4. And it has a question to list 3 protocols in addition to ICMP that can be filtered by an inbound protocol rule. Well, there's a whole list of them here. IP version 6, TCP, UDP. Choose any 3 from that list and write it down in that question answer there as to, oh, I'm sorry, you don't have to write this down because it's a demo. Okay, now in the left pane, we're going to click the name option. Sorry, go back to IP version 4 and click name. And I'm going to make a rule that says something like, what does he tell us to say? Allow ping requests. Make any name you want there. And then I would click save, finish, save, and that would save this rule. Now, I'm going to go ahead and save it because I want to show, and they're showing you how to delete it when you're done. And I'm going to delete it back when I'm done. See, there's my new rule at the top of the list, allow ping requests. That's going to allow incoming ping requests to come into this machine. Okay, let's disable this because in many of the Cisco Network and Academy labs, I can tell you guys, there are over 10,000 network academies in the world today. We've had over 10 million students. We're the single most successful e-learning initiative in the world for over 20 years now. I've been teaching this for 20 years. They've been in existence for about 21 or 22 years. So in many of these Cisco laboratories, they use like student machines that are normally used for other things. And so the Cisco Network Academy students will tamper with something on a regular production desktop machine, then they're supposed to put it back the way it was. You know, the rules for living from kindergarten, if you use it, put it back where it was. We want to put the machine back the way it was. So in here, I have virtual machines. You can mess with the virtual machines and you can't ever hurt anything. I can always re-ghost it or re-image it the way it's supposed to be. So we're going to disable the new rule that we did. So I'm going to click on my allow ping request rule that is made, and I'm going to say disable rule. And that's disabled, but I'm just going to delete it. Click delete, and it's gone. And so this PC that I use for teaching is restored to the normal operation. Okay, so not so much for that particular lab. Now, let me make sure I didn't hose it here. I'm going to check and make sure that I didn't destroy something. And how can I check for that again? Make sure my ping is still restored here. So if I type ipconfig, I'm on PC A, I should be able to ping. Didn't we talk about this earlier? When you do ping tests, there's a certain process you go through to try to determine where the failure has occurred. So the very first thing I'm going to ping is, didn't I talk about 127.0.0.1, the loopback port? That just makes sure that the TCP/IP button is checked in the network control panel. If you uncheck that, I know you guys will find this hard to believe, but TCP/IP has not been as popular always as it was today. For many years, there was a Novell protocol, so many computer workstations did not have the TCP/IP checked. They had the Novell IPX SPX clicked. In the 80s and the 90s, Novell was the king of networking, local area network stuff. So that worked. Now I'll try to ping my own IP address, 192.168.1.10, I think is what I am. I should be able to ping, always should be able to ping the 127.0.0.1. I should always be able to ping my own IP address. And then I'll try to ping my neighbor's address. So I restored the functionality there. And let me make sure PCA can go back to PCB. So PCB 127.0.0.1. We'll just go through the steps again. That works. Ping his very own address, 192.168.1.11. And then see if he can ping back to the PCA, because PCA is the one I tampered with. Make sure I didn't hose him. I'm getting good replies, so that worked okay. Okay, now the lab that you guys are going to do today, and I'm going to step through the whole thing now, is this lab observing DNS name resolution. And we're not going to use the PCA and PCB for this. We're not going to use the VMware because it requires access to the internet. And remember I told you that the bad thing about teaching networking and protocols and stuff like that is we do dangerous things. And the network managers and the upper administration doesn't want us hosing the librarians or something like this. So we have to do everything we can to isolate our stuff off the regular network. So we have our isolated backup equipment. We have our isolated PCA, PCBs. They don't plug into the TCC-SC connection. That blue wire that comes out of the back of your PC does connect to the college connection, and the other wires connect to our racks back here. So I'm going to go ahead and gracefully shut down these PCs. Now you can click start and shut down, but there's a little trick here. You can go down to the VMware thing and then click on the little orange stop button for both of them, and that will gracefully shut them down. If you log off of your PC or shut down your PC, don't shut down your PC when you're done here, by the way. Their updates are coming tonight. Always when you leave the room, just log off. So they both look like they're shut down gracefully. Good, they are, and I'll kill VMware. Okay, I'll start now with observing the DNS name resolution. So I like to call DNS the Directory Information Operator of the Internet. People cannot be expected, you cannot, not networking fundamental students alone seem to be overwhelmed with 32-bit IP addresses and 128-bit IP version 6 addresses, all these binary and hexadecimal numbers. What about your normal users? You expect them, if they want to go to Microsoft.com or Facebook.com or something, they're supposed to key in some 128-bit binary value? And what is it today? No, they can't do that. They won't do that. They won't do that. They just won't put up with that. They expect to type in what we call a friendly name, or a high-level name like Facebook.com or Microsoft.com. They're going to type that in. And what happens when you type in that into your web browser or any other transaction that involves going to a host name like Microsoft.com, what happens is the computer internally does a little side transmission with your local DNS server, and that's normally going to be, let me bring up my IP config panel for my machine here. I'll go to the DOS prompt. I want to show you these values. So if I type ipconfig by itself, I just get the basic information, but I want the ipconfig, I want to see the whole enchilada. We used this previous lab because we wanted to know what the MAC address was. There's the MAC address, the physical burn-in address of the Ethernet adapter that's in the machine that connects to that. Says all that TCCD.net. That's our production college network. There's a couple of extra NICs installed in these machines. They're not connected to the production network. We're interested in that one. So in our production network here, here's the IP address that was issued by a network server called a DHCP server. He gets automatic addresses out. The button is checked and says obtain the IP address automatically, because in the real world we don't have to run around and statically configure thousands of workstations. It's too cumbersome. Now I've been in networking. I'm the gray beard of networking. I've been in this field so long, I can remember that previous to about 1995, there was no such protocol like DHCP. We had to statically configure everything, every employee PC, every student PC. So in business, that's a big problem because people are always moving around from office to office. In the facilities management field, they call these MACs, moves, address, and changes. So the guy gets promoted to the corner office. Now the phone man's got to move his phone number, go to PBX and patch his new phone number in. Now the computer guy's got to go and put him on the new, he's on a different subnet now, so he's got to put him in a different network address. So this can be a problem, particularly when I worked for Harcourt in the 90s. These are all Macintosh users because it was a lot of graphical layout and stuff. And the thing about Macintosh users is they already know everything there is to know about computers. So they would simply put in whatever number they wanted to there and it would mess it up. So when this thing came out in 1995, oh, this is good. I don't have to maintain any Excel spreadsheets with lists of valid IP addresses and lists that have already been allocated and run around and change people's addresses when they move from one office to another office on a different floor. So I brought this up because I wanted to show you the DNS servers. So like most big companies, Tarrant County College maintains their own DNS server. This is a server that listens for requests. This is a quick and dirty request. We talked about TCP and UDP very briefly. Most stuff we send, like if I send an email or download a service pack, it's TCP, positive acknowledgement and retransmission. I want to make sure the file is perfect because it's a gigabyte service pack or something like this. Can't have any of the bits flipped or it'll crash. But some types of things are quick and dirty. So, for example, if you watch a YouTube video or you listen to an MP3 file or something like that on the internet, they can't stop and positively acknowledge each and every little bit of that or the music won't work right. You know, you've been on YouTube and you get the scrolling thing. If you don't get enough bandwidth, that's what would happen. So when you send video and audio, streaming IP phones, stuff like that, we use UDP, quick and dirty. We don't have to wait for this positive reignite. If I lose one little bit of a frame, there's a flicker in the screen, so what? DNS is like this. If I want to make a request from the DNS server and say, what is the IP address of Cisco.com? A quick and dirty request is sent. It doesn't set up the connection first. You know, I like TCPs like when the long distance operating person-to-person phone call, the operator comes on the line, makes sure both parties are there, and then she lets the call go through. With UDP, there's no such thing. She sends it out, blasts it out. Hey, UDP server, if you're listening, what's the IP address for Cisco.com? And one of the DNS servers, there's always two or more because they might be overwhelmed or one might crash. So I'll send that back to me. Okay, I'm supposed to go to, in the middle of page 1, go to the step 1 and look at the DNS conversion. And we're going to use, first of all, we're not going to use this word program you've never seen before. We're just going to go, and he says I'm supposed to ping Cisco.com. So this is why we couldn't do it in Packet Tracer. Packet Tracer has no real connection to the internet. This is why we can't do it on our PCA and PCB here in the laboratory room, because we're isolated from the internet, so the network managers here don't get mad at us, you know, and upper management says, oh, you're going to teach them how to hack, and they're going to break into the web advisor and issue themselves all A's and tuition refund checks. We can't have that. So he says we're supposed to ping Cisco.com. Cisco Network Academy. We could do Facebook, it would work just the same. So, ping Cisco.com, Cisco.com. There's the number, there's the network number, the network identity, which is kind of like a telephone number for Cisco. So if you wanted to call Cisco on the phone, could you say, call Cisco? Would that work? Maybe on your little cell phone, yeah, if you put the number for Cisco in it, call Fred, call my buddy Fred, yeah, it knows the number, he dials it for you. So what happens is I would have to pick up the phone and dial 411 information. What's the telephone number for Cisco? I want to order a switch. And he would give me the number. And then they would say something, they see something like, for $1 extra, we'll dial it for you. So DNS does it, he dials it for you and doesn't charge you the $1. So what happened is before I ping, echo request, echo replies, the little side communication to the DNS server says, Mr. DNS server downtown at the data center in our Trinity River campus downtown that we bought from Radio Shack. What is Cisco.com's IP address? And he replied very quickly, and this is the address that was returned. Now, my computer can create the pings, echo request, echo reply. You have to ping a number. You can't put a packet. You can't create a packet that says ping Cisco.com. It wouldn't work. It has to be a 32-bit proper type of IP address. Network portion, host portion, like a telephone number, area code, telephone number. And so I was able to ping them. Good. We don't have any kind of rule here prohibiting outbound pings. Now, in some companies, pings are considered a security violation in that someone could use it to map the network. So many companies don't allow incoming pings. So you might try to, if you try to ping something at home and it doesn't work, it may be that company is simply not aligned that. Okay, so what IP address is shown on the screen? Now you may get a slightly different address when you do this, because Cisco is a big company, they have lots of servers. I got 72.163.4. It says 161 in the lab report. It says 4.185 on mine. Big companies normally have dozens of servers, and they have a thing that when a request comes in, it'll load balance it and send it to the first free server. Okay, what does Google got? Like 1 million servers? You never know which one you get. Their mechanism will automatically distribute your request to a free computer, and he'll look up your request for you. So it says which IP address is shown on the screen. It's probably not going to be the same as what's shown in the screen print for this. Okay, so I'll go to page 2 now. Should Cisco.com always resolve to the same IP address? Probably not. Because they have dozens or hundreds of devices on their network accepting outside connections, you might not get the same number. So it says work together with another student and discuss 1 or 2 applications in which the computer would need to use DNS to translate a domain name to an IP address. How about going to a website? You open up a web browser, you type facebook.com into it. What's got to happen before Facebook is going to be able to accept your name and password? Your computer needs to know to create that login request to Facebook, the actual IP address for the Facebook server. So DNS has to, so you have to test your local DNS server at home. You guys are cable, right? Anybody here not cable? Your phone company? Yeah. Early, I am too. I'm usually the only one. So I've got the phone company thing. I've got the phone company integrated box. It's a Wi-Fi and home router and all that stuff in one box. I think the cable companies are doing, you guys are on cable. Do you have a separate cable modem and your own home router, or did they give you one box that gets the Wi-Fi in it? The one box? You have the one box? Yeah, that way they can charge you $10 extra a month for Wi-Fi, right? Okay, so I'm going to go to step 2 now. Verify a DNS operation using a new command we've probably never ever used or seen before called NSLOOKUP. NSLOOKUP, name service lookup, excuse me. So it's a tool that we use for troubleshooting and testing the DNS servers to make sure they're looking up stuff. We're going to use it to look up Cisco and also look up Cisco's mail service. So I'm going to type NSLOOKUP. And this is going to work when you guys do this at home. So we're doing this here in the lab, not PCA, PCB, just your regular Windows 10 desktop, which has internet access. The people that are doing it at home, this will work from any Windows computer. This will work from any Macintosh computer, probably work from any Linux-based computer. And I've got this new prompt here. And it says, what is the default server listed as? This is Tarrant County College Data Center downtown, where all our server computers are located. Now, many years ago, we had our own servers. And we had a server closet that all our rack mount servers, they mounted racks similar to these. But the current trend is don't put them all separated out in different places. It's too hard to manage them and back them up and so forth. Let's put them all in one place, and we can all back them up and protect them and put a real big firewall around them and stuff like that in one place. This is what most companies do. They use a data center type location. So all our data centers are downtown, and our speed of our data communications between the campuses, which used to be kind of slow, which was a big problem for Microsoft, because Microsoft It's very cumbersome when he logs you in. He puts your name and password in. We used to have to put little domain controllers at every campus to log you into that campus. Otherwise, it would take 30 minutes to log in. Well, now the speeds we have between the campuses are faster than the speeds we have in the rooms here. So we can put our servers anywhere. So that 10.109.11.17, does that match the number I had earlier here? Let's see it real up here. Oh, it matches what's up here. 10.109.11.17. Okay. So I got the first available DNS server. They use two, so if it's overwhelmed, it'll just round robin go back and forth. So after issuing the previous NSLOOKUP statement, it changed from the normal prompt. The normal DOS prompt is a letter, backslash, something like that. It might have your name in it. It changed to this caret sign, or greater than symbol sign. So let's see, and we're supposed to type the question mark prompt, which is similar to the prompt we would use when we configure Cisco devices. We aren't quite ready to configure Cisco devices yet. But many operating systems have this thing. You just type a question mark, it'll show you a built-in help command. And these are all the commands you can issue from this. So what are 3 commands I could use with NSLOOKUP? Well, just choose 3 and write them down in your lab report. Okay, now we're supposed to type little command C, little step 2, little letter C, type cisco.com. Now before I type ping cisco.com, I looked it up. But this is not ping. This is just looking up the name request. So I've got this is our DNS server downtown, and then this is Cisco in California somewhere probably, and this is an address they came up with. And notice they have this other address here. So this is an IP version 4 address, 32 binary bits. We render it in dotted, what we call dotted decimal. Every period, but each period separates a 8-bit binary byte. Any number between 0, 2, and 55. This is an IP version 6. Which we've only briefly looked at in this course, which was the solution to back in the late 90s. We started running out of network addresses, so we had to make up a bunch of new numbers. In the telephone company, we used to have one area code for Fort Worth, 817. We used to have one area code for Dallas, 214. Now we got a dozen area codes. Because in the 90s, everyone started buying pagers and dial-up Hey Screeching Cats modems and fax machines. And I put in a line from my teenager, and we ran out of phone lines. So they had to put in a bunch of new area codes. So the similar thing was happening in networking. We were running out of available 32-bit IP addresses because they'd been given out in an inefficient and wasteful fashion. So what we did was come up with more bits so we can use more numbers. So that's what we can now call IP version 6. We used to call it IP next generation, but in about 2000, we started calling it IP version 6. And it has 128 bits instead of 32 bits. So now every refrigerator and thermostat is going to have an IP address, parking meters, everything. Okay, is the IP address an IPv4 or IPv6 address? Well, we got them both. We got the IPv4, the dotted decimal, and IPv6 has colons instead of periods in it. Is it the same address that was shown with the ping command? I think it's slightly different than the one that was shown with the ping command. Let me see, where's my ping? Oh no, it's the same. It's the same address. It's 172.163.4.185. It's showing the same address. Okay, it says at the prompt, type the IP address of the Cisco web server that I just found. I think he means I'm supposed to type 72.163.4.185. And he does a reverse lookup and tells me what the name is. Now, we're going to do the mail portion, and then we'll be pretty much done. So the 2 big killer applications that drove the growth of the internet, even before we had the web thing. You guys know about Tim Berners-Lee, English guy. He invented HTML, web stuff. Before that, we had a killer application. Email, sending what I call nasty grams between the boss and the employees or whatever. They send stuff by email, and they didn't have to mimeograph stuff on paper or send stuff to them anymore. So email was a big killer application on the internet. We had a little bit of file transfer. There was a program called FTP that could transfer files, so you could go to Microsoft and download Service Pack for Windows NT Server, something like this. But really, the big thing in the early 90s was the development of the web. And everybody went crazy going to every web server in the world. And it's like the cartoon where the wife comes in and says, husband, I should have come to bed. He says, no, there's something wrong on the internet. And he's just consumed with going to every internet page and find out what's wrong with it. Okay, so we're going to go to step 3, and we're going to look at the mail server, because Cisco, all companies have email services. So let's look what happens here. We're going to set type equal MX. MX is a code for how mail is processed, and then say Cisco. Now this time, look, we're getting, mail exchangers. These are the servers that exchange mail between Cisco customers and other people. And here are some mail servers that Cisco has. They normally have several of them because they get lots of mail. Just for fun, I'm going to step away from the lab 1 second, and I'm going to say tccd.edu. Well, look, Tarrant County College has got some mail servers. Well, we got 100,000 students. We got 4,000 employees. Yeah, by the way, did I say this? I forget I said this in the lecture. Did you know that Tarrant County College is rated by Forbes magazine as one of the best 100 places to work for? Don't tell that to our human resources department. They're evil, but once you get hired, you're okay. So on the top of page 3, it asks some questions. What are the names of some of the Cisco mail servers? They're identified in the mail identifiers. Then it says at the prompt, type exit. So I'm going to type exit, and it's going to go back to our standard DOS prompt, command prompt. And I'm supposed to type ipconfig /all. And the question is, what is the address of the DNS servers that your school computer uses? And it's these 2. 10.109.11.17, 11.18 are our 2 addresses. Okay, I don't require the reflection questions. So type exit and complete your lab. Hang this, I'm going to stop the recording.